All right, guys, we got the fresh Toyota Tundra, the newbie, towing the old heritage Toyota Stout 66, and we are here. So we are here at Kibbetech, and Ryan and Matt. Ryan is the owner, Ryan Kibbe, and then Matt, who is the CAD designer and main engineer here, and designer as well. So these guys are actually going to be designing and manufacturing the CAD design tube chassis frame that we're going to put this thing onto. So we're going to be using some of the body, and then we have a bunch of other plans for it too, but as of right now, Kibbetech is designing in CAD the tube chassis frame. So we're here to drop this thing off, get a tour of the shop, and check things out. So Ryan, I met over 10 years ago with Hoonigan, maybe even longer than that, maybe like 12 or 13 years ago. And his business has grown exponentially massive. So he's doing a lot of really cool stuff, him and Matt together. So let's check it out.
Towers are proprietary, the tables are proprietary, they're all built in the computer, and then basically we just bring them to life, and we use them however we want, but all these fixtures down there are for that truck.
So yeah, this truck was built 100% in the computer.
100% on the computer, yeah, so Ryan and I agreed that we're not going to have any fabricators touch it unless they're like fitting a laser cut panel. So the idea is to have this one 100% done on the computer, and we have to duplicate it or make extra parts or replace parts in like an accident or something. We just pull it out of the computer, have another one laser cut, replace it, and put it back on the table with all the fixtures. And that's the fastest way to make it happen.
Yeah.
Like the most proficient way of doing it. So.
Definitely sounds efficient for sure.
Yeah, definitely the most proficient way.
Right here, you can see the F-hole steer. There's plenty of clearances.
Oh yeah.
And that's the C7 rack.
Yeah.
Yep.
And back, that winner's quick change.
Yep. So yeah, that actually looks really cool. I mean, the radiator is not bad there. If that's how we would finish design everything.
Yeah. So actually, so this is what I was saying. You see how low this is?
Yeah.
So what I want to do is I want to bring this tube right here up around here.
Okay.
And then lace it so that it's a little higher. These tubes will come out a little further, giving us more radiator room.
Mm-hmm.
Then I'll just build a bracketry that ties this lower member to the top tube, and then tie the arms in that way.
Okay.
Rather than off the sides like that.
Mm-hmm.
So it'll be kind of captured underneath it. There'll be enough stroke in there, and then we can have, I mean, we'll get the coilovers in there, they'll still fit. We also have the option of adding a cantilever if you wanted. So that's still
an option.
If
Okay.
you want. Obviously there'll be some sort of more than likely a machine hold down for that, or the cell that we end up going with, right?
Yeah.
So once I get the dimensions for that, then I'll make the cradle for it, and then the cover for it as well.
Okay. The cell is very basic. It's just a 10 gallon. That's a rectangular shape.
It's very basic.
That looks a lot cooler because it's more shapely, but.
But yeah, so this is 15 gallon. So the one that you're gonna send is gonna be quite a bit smaller. So yeah, so he's saying it's gonna be a 10 gallon.
It's like 14.
He's around 10 gallons on it.
Yeah, because we do 2 laps before the tires are smoked, and we got to come in and change, do fuel anyways. So.
Right, and then that'll give us more room for the quick change.
Yeah.
Also.
Yep. Yeah, because we want to be able to change gears on the fly, not have to remove anything besides the back cover.
Right.
All right, guys, so Matt has done a great job on the first edition of the design, and we're going to keep the base of everything and start making some tweaks as a part of what I need changed and a couple small things that I want. So we're going to do rear cantilever suspension. So he's going to change the rear. We're obviously going to be running a Radium 10-gallon fuel cell. So we're going to change the back end to design around that. And then in the front end, we're just gonna make sure we have all the proper clearance we need for 9.5-inch wheels, utilizing the Power by Max Corvette suspension kit, and just a couple other tweaks here and there. But overall, this thing is looking sick, and I cannot wait to get it finalized. What's up, guys? We are here at ADV Advanced Fiberglass Concepts, and one of the owners we're going to be talking to, John, has worked with me for the Toyota Stout, and we bought a bunch of high density foam. He's going to be cutting that on a CNC router and making some of the most badass fiberglass parts that I have had the pleasure of putting on a vehicle. So let's check it out. What's up, guys? We're here with John, one of the owners of ADV Fiberglass, and so he's going to bring us up to speed on his company, how he got started, what his background is, and what drove you to wanting to make some of the best fiberglass components on the market.
Cool, yeah, so to be honest, it's a family business, and I started actually running it about 5 years ago, and beforehand it was all done by hand. So they basically get a truck in here, they would hand shape on the truck, so Bondo, foam, shape it, then take templates from left and transfer to the right. So we did a super good job at it, but nothing compares to our CNC machine over there. That thing is awesome, and I'll show you that in a little bit.
Yeah, well, that thing looks massive from here even.
Yeah, but from now on, it's strictly the machine, because the machine does all of the work. Obviously, you got to make the CAD file, then you got to make the program for it to CNC, but you press a button on the machine, let it run, and it's done. You got a CNC machine, it's covered in foam as well. We do our best to keep it clean, and the reason being is if you keep it clean, you can make sure there's no problems with the machine, or try to make sure there's no problems. But to walk you through the process right now, we basically have a CAD file that my CAD designer will make. He'll send it off to us, we'll approve it, we'll tell him how we want it flanged as well. We'll flange it in the computer so you can tell the part is at this line where my fingernail's touching all the way across, and you follow it all the way through. And basically we have a flange on this part, so we can pull multiple molds from this fender. And this fender in particular is going to be our Bronco fender for the new 4-doors. We CNC program it, set it up on the machine after the block is glued together, let it run, and it actually makes this right here. After it's made, which is, well, actually over here, this is fresh off the machine right now. This is the front side of the flange, and you got the back side over there as well.
Okay. Yeah.
And then this is the mirrored side of it as well. We basically will just lightly sand it and then prime it. So we put about 10 coats of primer on, wet sand the primer so you get a mirror-like finish like that over there. Put the release on and then make our epoxy mold. So it sounds simple, but let me tell you, it's a lot.
You make it sound simple. Well, dude, this is sick. Let's look at the CNC router.
Cool. I already pulled a part off of it, so right now I got it cleaned up. We're gonna prep for another part, but the way we do it is we center out the machine with wherever we're gonna put the part on. I'll trace out where my risers are gonna go. So we basically have a form, and this shows you the back of the foam. This shows you the plywood. So I basically label out where I'm putting the risers, which is that and that right there, to raise the foam off of the actual plywood. Okay. And the reason that we do that is if you have a full 5-axis machine.
That's these routers right here.
Yeah,
or these risers right here.
Yep, exactly. Because what happens is majority of the time, you need to come down all the way at B90, which means that machine right now comes down like this because you have full 5-axis movement and you don't want to hit the table itself.
Yep.
So you rise it off, that way you can get all the detail you need.
Yep.
So
makes sense. Makes sense. This thing is massive, dude.
Yeah, the pictures don't do it justice. I mean, once you stand by it, I'm a little short, unfortunately, but it's still a big machine.
It's a big machine.
Yeah.
So that's the head over here.
Yep. So you can tell rubber, and then it slowly goes down to ball nose, and then tapered ball nose. And as you can see, they get smaller. Yeah, you gotta be really careful with that one.
Damn. How, do you have to sharpen or replace this stuff at all, or does it last quite a while?
It does last a really long time because we're only cutting foam, so that's the benefit of it. I have never replaced, obviously, the rougher. We have replaced the inserts because over time the inserts need to get replaced, but I've honestly only replaced this tool because that's my main finishing tool. Other than that, I've broken a few tools, unfortunately. I'm not gonna lie, it happens, but we've replaced a few of them. But besides that, they're really good quality tools, and we're only cutting foam, so it's not metal.
Yeah,
it's
exactly.
Yeah, exactly.
Yeah,
so.
yeah. Well, we do have a bunch of footage of my stuff getting cut on the CNC, so let's check it out.
All right, we finished up all the CNC work for Ryan, and now we're actually gonna start making the molds. So right behind me right here, we have one of the bumpers for the front of the truck. And what we're gonna do is, he's gonna start applying some filler. We're gonna align a few layers of material on top of the plug itself, let it cure overnight, gel coat the opposite side to make the other flange, pull it on Monday and make parts on Tuesday. That way we can get it all fitted up for Ryan's truck. So right now he's applying some filler to the sharp edges, and the reason that we do that is so that way we don't have any voids, because material is hard to get in the tight corners, so the filler compensates for those areas. All right, so one more explanation. My guy is actually laying down what we call rope right now on all the tight corners as well. And what that does is it helps make the edges a lot stronger, so when we pull the molds and we demold parts eventually, it does not break. All right, so this is the most important layer out of the entire process, and the reason being is it is the first one. So you can't risk having any voids. If you have any voids, meaning like air pockets or any inconsistencies, that first layer is gonna show up with the gel coat. Once you demold the part, you're gonna have inconsistencies there. So it's very crucial to spend time on this exact layer right here. To squeegee it, to put the resin on top of it and make sure it's consistent all the way through. And that way you get a nice solid part. After the first layer, we're gonna add a few more layers to stiffen it up. That way when you demold it, it doesn't twist at all. So this part right here is actually gonna be the splitter. So it sits on the bottom of the bumper itself on the front of the truck, and it's actually gonna be a two-piece mold. We have the top side, which is right here, and then over there we have the bottom side. And the reason that we have to make two separate pieces is because if you make one mold on top of this entire part, it's gonna lock in place. You can't pull it. It'll be just a mold. So what we do, we make this mold right here, we make that mold over there, separate them, lay them up separately, combine them, let it cure, pull it off, and you got one single part from two separate molds. What's going on, guys? It is a couple days later and we have finished up Ryan's mold. So right in front of me right here, we actually have the bumper. So we got 3 fiberglass molds. We have the fiberglass bumper mold and we have 2 splitter molds. One's gonna be the top splitter mold and one's gonna be the bottom splitter mold. And the reason behind that is, like I said before, we're gonna combine both parts to make one finished part in total. This right here is gonna be the fenders. We have one fender here, another fender right there. We got one bedside over there and then one right over there as well. So what's gonna happen next is we're gonna lay the part up. But to begin, we've actually got them all gel coated. We do a 2-stage gel coat on purpose. White as the first layer, then a gray as the backing. The reason behind that is if you do a single stage layer, so let's say just white over the entire surface, and you pull the part out, you can probably see directly through it because sometimes it's not a consistent layer all the way through. So by doing a 2-stage gel coat, white front, gray backing, and you hold it up to the sky, you're not gonna see through the part itself. So that's all cured up, they're ready to get laid up. Our guy is now measuring each individual part or plug, that way we can cut the right length of material to lay it up itself. Once it's all laid up, we're gonna add resin, squeegee it, make sure it's all nice and clean, trim all the edges, let it sit overnight and pull the part tomorrow morning and grind it down and send it off to Ryan.